Hello, everyone. Welcome to JAC Istanbul's another meeting, and we are super excited to have Venkat here. I will briefly introduce our local community, and then we can continue with Venkat's presentation. And you know, our Java user group Istanbul is the most leading Java community in Turkey, and we are doing lots of meetups and regular conferences like Java Day Istanbul, and also we attend to Global Day of Code Retreat organizations, and time to time we are contributing to Jakarta EE organizations. And here is our, as you know, our website for the quick access. You can access all information from here, like our podcasts or Java Day Istanbul or our Meetup Slack channel. Or if you want to become a speaker, you can also fill that form. So this is what I wanted to introduce very shortly. So we have Venkat. Welcome, Venkat.
Thank you. Thanks for having me here.
Yeah, you're most welcome. Venkat will be presenting us about the awesome features. So I don't want to waste so much time and make Venkat stand here. Just a second.
Also, I would like to thank you, Venkat, for being here with us for all valuable informations. Thank you very much.
Thank you so much.
Yeah. So you can share your screen, Venkat. And by the way, for the audience, sorry, we have the questions section in the UI, so you can ask your questions, or if you have any issues, or you can interact with us with the questions. We will forward your questions to Venkat in the context, so don't hesitate to ask questions. So this is what I wanted to remind. Thank you.
Oh, very good. Well, thank you so much. And quick confirmation, are you able to see my screen with the text on this?
Yeah. Amazing features of modern Java. Yeah.
Wonderful. Well, first of all, thank you so much for having me, and thanks everyone for joining here today. Before we get started, the best time to ask questions or make any comments is anytime you have a question or a comment. So please don't wait till the end. Anytime along the way, post your questions, and we'll take those questions as you post them. So let's make it as interactive as we can. Again, thanks so much for taking the time to join. It's a great pleasure. I really wish I could be there in person, but I'm as excited to be here remotely as well. I want to talk about some of the exciting things going on in Java. For the next about 85 minutes or so, we're going to dive into certain features in Java that are fairly exciting in terms of the evolution of Java. But of course, back in time, I used to say Java 8 was the biggest release of Java. Well, since then, Java 9 was the biggest release of Java. But now, of course, as you know, Java is on a 6-month release cycle. So what that means is every 6 months, March and September, we get a new release of Java with most likely new features in every single version. This is pretty exciting, and I want to really emphasize on that before we go any further to say that Java is not being really developed on a 6-month cycle. The development time is taking as much time as it is needed. Some features are taking 5 years to develop. Some features are taking 7 years to develop. It doesn't matter how long a feature is taking to develop, it's being developed with quality, there's no change to it. But the release cycle is every 6 months. So what that really means is they're not arbitrarily grouping features together and delaying the release of a certain feature because they have to wait for something else to be available. There's a train that's leaving every 6 months, and when a feature is ready, it can get on the next train that is leaving. And that is basically the release train of every 6 months. But let's get down and talk about some exciting features in Java. Well, back in time, we had switch statements, as you know, but now switch is also an expression. Now, expressions do not cause mutation like statements do. So there's a really good power to having expressions. Let's dive in and look at this with a little example to see how that's going to feel like. Let's go ahead and call a little function here. We'll say output process. And in this case, we will call process with a 1, but we'll call it with a few other values as well right in here. Let's call it with a value of 2, maybe a 3, maybe a 4, and oh, maybe a 5. Let's play with this a little bit and see how this could work. So I'm going to say public static, let's say a string, and we will call this as a process function, which takes a number as an argument. Now, what I can do within this function is, let's just start with a few baby steps. I just have an empty string, that's all I have, nothing really exciting right now. But instead, I'm going to say return switch, and I'm going to put a number on it and put a little curly around it. Well, notice the first change here, putting a return in front of the switch. Of course, you cannot return statements, you can only return functions, or rather expressions, if you will. So switch is an expression in this context. So we can say default like so, and we can simply say I want to return whatever as a response from this call. So in this particular case, we are saying I have a default, and notice the very first difference. We used to use a colon as part of statements before, but this is not a statement, but it's an expression. So we changed that colon into an arrow like so, and now you can see whatever being printed on the output. Now that we have a switch expression, I can say case 1, and if it's a 1, I can return a 1 like so. So it says 1 for the first one and whatever for the other values. So that gives us a nice way for us to write a switch as an expression. But did you notice one thing though? If this were a statement, unfortunately, it would have returned whatever for 1 because I forgot that silly break statement. Well, as I mentioned, break is a statement, but we're working expression here. So there's no more break. So you don't have to worry about forgetting to put the break. It's less error prone, less noisy as well. So there's an automatic break at the end of every case when it comes to a switch expression. So that's why you don't see a break in here. Now I can, of course, take this and say a 2 or a 3. And I can simply say 2 or 3 like so, and you can see the output is 2 or 3 right there when you see the output. But what if I really want to write multiple lines of code to perform some operation? My recommendation is write that as a separate method and call it. That is a better way of programming. However, syntactically speaking, though, you can do the following. You can put a little curly brace like so, and here you can say doing, let's say, more work, and whatever that more work may be, and you can return a value of 4 from here. But this won't work. We'll see why in just a second. It says not a statement. What's going on here? Well, obviously, we need to return from that particular multiple line block, isn't it? However, if we put the word return over here, that's a bit confusing to us, isn't it? Does the return mean return from the expression, or does the return mean return from the function itself? So in order to remove that ambiguity, we don't use a return, we use a yield like so. So now you can see it says 1, 2 or 3, 2 or 3, doing more work and a 4 and whatever for the value of 5, as you can see. So that shows us the switch as a expression in this particular case. So a few differences that are noteworthy. First is, instead of a case with colon, we write in this case with arrow, if you will. So that's one of the very first differences, case with colon versus case with arrow. Also notice the semicolon at the very end. You don't need to put a semicolon for a switch statement, but you do put a semicolon for a switch expression. That is another difference that you see in here as well. And so we wrote it as a switch expression. As a result, we don't have to mutate anything. But of course, if you really want to, you can say over here a message equals, and you can come down after the switch, and you can also say here something like return we got plus message, and you can really write it as an expression as well, and then use that expression later on, and you can return the value. So you don't have to return from a switch. You can also assign it to a variable and then make use of that later on as well. So hopefully that gives you an idea how you can use this as an expression rather than as a statement. Now, of course, you still have access to the statement if you really want to use a statement, but you also have an expression. So switch could be used either as a statement or as an expression. Very quickly, you can look at the switch and see there's a colon, it's a statement, there's an arrow, that's an expression. That's an easy way to know the difference between them as you look at it. So that's basically about how switches can be expressions. Again, please don't hesitate to post your questions or comments on the question, and we'll be interactive along the way. So please don't hesitate. And of course, if you really like a particular feature, you can definitely post that on the chat as well. Make it interactive. Maybe you're a big fan of a switch expression. If so, you can also say that you really like switch expressions, or maybe you don't. That's perfectly fine to have that opinion as well. So that's about a switch expression in terms of what a switch can provide for us. Now let's move on to the next topic here, talking about switch blocks, or rather text blocks. Well, the interesting story about a text block is it first started out as providing a raw string, and they dropped that idea and postponed the release of text blocks to a next version. And that again reflects back on the very agile mode of operation where they develop things and get feedback, and then based on the feedback, they go back and change and make improvements, and then they make the releases. Well, text blocks really represent multi-line strings. I've used multi-line strings in other languages before, a feature called here docs, but I have to admit, I am really not that happy with implementation in some other languages. It works mostly, but suddenly it would start misbehaving, and I would waste several minutes to get it back to work. I'm really appreciative of what folks behind Java have done with the text blocks. I will talk about the concept of innovation in Java related to this a little later on to show how this can be really a powerful mechanism to implement with text blocks. Well, in the past, what did we really do when it comes to writing these kinds of code? I'm going to also give you a little bit more insight into how this works as well. So I'll come back and show that in this particular screen as we go along with this particular example as well. But for now, let's talk about the past of Java. We all have done this code, isn't it? We said string message is equal to something like hello there, and then we wrote a message over here, let's say a message plus equal to, so we could say in this particular case, a message plus equal to, how are you? And you could even put double quotes with the U on it to emphasize the U. And then, of course, we could say message, and we could say plus equal to, thanks for, visiting. And you can see finally we could output that message in the very end. Now, we all have written code like this, isn't it? But let me ask you honestly, would you put that on your resume? Would you tell your potential employer, I have 7 years of experience using plus equals? No, right? This is the code you would hide from humanity. If you are working from home, if a child walks into the room, you would quickly shut the monitor. You never want the next generation to see a code like this, isn't it? That's a very smelly piece of code. Shutters, we don't want to write code like that. So this is where text blocks can come in really nicely for us to use. So let's say a greet right there, and I'm going to say, Istanbul jug, and I want to greet the jug right there. But we'll come to that in just a few minutes. Let's write the public static string greet, and we will say a string, let's say name. But in here, what am I going to do? First of all, I'm going to say a string, let's say a return, and we will write a multi-line string like so. So we put 3 double quotes, and we're going to be writing multiple lines of text right in there. So we say in here, hello there. We'll bring in the name a few minutes later. And I'm going to say, how are you? And again, I can put a double quotes without really using a special escape character. You can just drop in a raw string in there, as you can see in here. Similarly, I can say, thank you for visiting. And I can write that piece of code very easily, as you can see right there. So you can see it says, hello there, how are you, and thanks for visiting. And we can write all of that very nicely. But let's talk about a few innovations when it comes to this. One of the very first innovations in here is, if I were to put a few dashes before and after, notice where the dash is and where the H and T are, they're all lined up vertically. So this is called smart indentation. So the compiler knows that this indentation is for the code and not for the text, essentially. So Java has what are called the incidental indentation, for example, versus indentation versus essential indentation. So essentially, in this particular case, it says that indentation is incidental. It is there because the text is within a code and the code is intended. So it's an incidental indentation. As a result, it removes the incidental indentations and they are lined up vertically, as you can see. However, I can go back here and add a few indentation. This, by the way, is an essential indentation. So when you notice over here that hello, how are you is indented from hello, that's because that's an essential indentation. So this indentation here is still removed and this indentation is actually kept. So that's a smartness of the compiler to deal with the indentation properly, as you can see. So this is essential, as you can see in this particular case, that's basically kept in there and the incidental is removed, as you can see. Excuse me. So that is an example of how smartly, the indentation actually works, as you can see in this particular case. Very powerful, isn't it? Now, given this, of course, there are times when you may want to really not keep the spaces that are at the end of these lines. So in the end of these lines, I got some spaces. Well, a lot of times you might be copying and pasting a piece of code, and as a result, those spaces are really a copy and paste. You don't care about them. So in this case, as you can see, if I say over here a dot replace, and I'm going to replace in this case a space with a tilde, if you will, notice that in this particular case, the output that you see is basically the tilde is right there in the middle, but there's no tilde in the very end, as you can see. So that has been stripped out, as you can see right in there. So the tilde doesn't appear on those two lines. That's indicating that the spaces were removed after all, and that's a default behavior. Pardon me. However, what if you said you really want those spaces? Well, you can then go down to the end of line and use this new special escape. That escape is a /s, and as you can see right now, there's no space at the end of hello there, but the spaces at the end of how are you are actually preserved, thanks to the /s. Similarly, there's one more special symbol as well, which is the slash. And when you run it, it can combine the lines together. So the thank you for visiting now has been combined with the previous line because of the slash. And that is again a new escape that's been added. So you see a special indentation. So you can see in this particular case, you saw the indentation, a special indentation. You have the incidental versus essential and how that works as well. Now, you might wonder how strings are implemented under the hood. Excuse me. What are the consequences of using a string? Are we going to lose out on performance? Maybe. Are we going to lose out on interoperability? Those are fairly good questions one could have while they are looking at the text blocks. As it turns out, in this particular code, you can see that we used a text block right here. But what is really a text block? To answer that question, let's get down to the command prompt for a minute. Here is a sample.java. Let's do samples java c -d, the current directory, and sample.java, and we just compile the Java code. So java p -c -b, all those are aliases on my machine. So let's simply take a look at the output of the bytecode that we see. And what you notice here is the greet function. But notice what the greet is doing. It says LDC, which stands for load constant, and it literally loads a string with the words hello there /n, how are you, and thank you for visiting. So that tells us the fact that in reality that what we are really looking at essentially is very simply put the the string itself and nothing else really, which is amazingly powerful, isn't it? Because at the end of the day, this is really a string and nothing else. So there's no performance issue. It's purely a compile time facility. There's no runtime text block processing. Everything is done at compile time. There's no interoperability issue, and also you enjoy the string interning as well in this particular case, because it literally is using the interning of a string because it creates a string in reality. There's really nothing special at runtime for processing text block, entirely a compile time processing, as you saw in this particular example. So we cleared a multi-line string. We don't have to escape using the normal escapes. You saw the smart indentation. We saw how we can preserve the trailing spaces and also preserve the line breaks as well. And of course, there is a newer function for formatting the data, and we can make use of that right here. Notice in this case, we said, hello there, how are you? Let's remove the replace method right now. We don't care about that anymore for our discussion. And when we run the code, it says, hello there, how are you? And thanks for visiting. But what I want to do is to use the name in the code after all. How do we do that? So you can simply say a %s, much like how you do the printf earlier on, and you can simply say a dot in here, and this is going to be dot formatted, and you can simply specify the name as an argument, and you can see that it says the name is being replaced right in there. So that function is a newer function in Java called formatted. But what does the formatted function do? So formatted is an instance function that merely calls the static function called format on the string. So that's literally what it is doing. It's just a convenience function. But why did they provide an instance method when there's a static method? Well, the reason is very simple. You can use it as an expression, and you can call other methods on it, and you can return the result of it also easily. So it becomes a nice way to chain functions on a string. That's why the formatted is a newer instance function that's been added as well to the string class. So that's basically the feature of the text blocks, and how text blocks can be really a useful and powerful feature that you can use in Java as well. Well, now that we saw two features, let's go on to the third feature. Once again, any time is a great time for questions, comments. It doesn't have to be a question, it could be a comment. You could talk about whether you like a feature or don't like a feature. Anything that you find interesting, don't hesitate, don't be shy, post it on the chat. There's a difference between listening to a talk on YouTube and being interactive. When you're on YouTube, you cannot ask a question or post a comment to the speaker, right? But I'm here live, breathing and smiling at you. So great time for your question, great time for your comments. So don't hesitate to post your question, post your comment. Otherwise, I would feel I'm posting this on YouTube and not to a live audience. So don't make me walk away. I'm gonna have people ask me later in the day, how's your talk? And I'm gonna say, I think I spoke to YouTube, not to real people. So don't let me say that. So be interactive, ask questions, post your comments. We are here for a reason, connected live. Let's make use of that. So the next topic I want to talk about here is about records. Well, I'm sure we all have written a lot of boilerplate code in the past, and that becomes really a lot of effort to write that code, isn't it? We want to be able to reduce that effort as much as we can. This is where the beautiful feature of records really come in. Let's take a look at an example of this to see how this goes. Let's say I want to create a location 1 equal to new location. Let's say 125.32 comma minus 84.2 and I want to output the location 1. But how do I create this class for the location 1? So you could say class location, and I'm sure we all have written code like this in the past, isn't it? So we say private double lat and a private double lon. And then you could write a constructor for the location, and double, we could say lat and double lon. And then we painstakingly write this dot lat equal to lat and this dot lon equal to lon as well. Well, then of course, you say you're not done. You write a getter after this. And maybe you write a equals method, maybe a hash code method as well. But then when you try to output the content, that's not very helpful. You write a toString method as well. And that's a lot of work, isn't it? Where you have to write so much code just to make this work. That's boring and a lot of effort. You could say, but my IDE can do all that for me. Well, that's called an IDE vomit. And the IDE is going to spit all that code, and it still is in front of you, and you have to deal with the IDE vomit every day, and the code is going to be really smelly, isn't it? That's no fun either. So as a result, the records can help us a lot in this area. So notice I remove all that boilerplated code and simply say double lat, and I say double lon as well. So now as a bonus, notice it gives us a nice output with the lat value and the lon value being displayed right there. So that's an example of a record. So what do records do? Records give us buy one, 5 free offer. What a great deal, isn't it? You just buy the record and you got 5 things given to you free. The constructor is given, the getter is given, the equals method, the hash code, and the toString. All the 5 things are given to you automatically. Plus the components, for example, lat lon, are immutable. That is, they are final. So you cannot modify those once you initialize them as well. That's another benefit you get out of this. Now the beauty of this here is, if I were to create a lat lon 2 and a lat lon 3, but this one, let's say, is 115, as you can see. So I can say location 1 dot equals location 2 like so, and I can also say location 1 is equal to location 3. As you would imagine, notice a true and a false as a response in here. So basically, you have a true when they are equal in value, false otherwise as well. That's basically a location that you see right in there. So as a result, this is basically an interesting way to create a very concise piece of code with a few built-in things. So when should you use a record? Use a record when you want to create a data object. That's what it really is for. It's a data object. So you're saying you want to simply create this class, which is a carrier of data. That's all you're interested in. So it's really a data object. That's when you create a record. So we talked about how they are immutable. You have a getter available for you automatically. So you can say, for example, location.get, in this case, lat1, and you can, or lat rather, and you can get the latitude directly in there. That's the getter that's provided to you as well, pretty nicely. And of course, a toString method is given, equals and hash code is given to you. You cannot extend your record from any classes. You cannot really extend any class or a record from your record either. They are implicitly final. You can implement interfaces if you want to. You can also add methods if you like to. You can even create a record within a function if you really wanted to. But of course, what about writing a constructor? Well, you can write a constructor. You can either add a canonical constructor or what's called a compact constructor. So for example, in here, if you look at the location 1, you can see that the location 1 was created. But what if I want to say, I want to verify that the values are actually good? So we can write a cat block right here with an exception, for example, and I want to output the exception right there, but I want to say new location, but I'm going to say 400 comma minus 300. Well, you know, and maybe for this we'll simply keep it as a 84 or a 48, whatever that we had before. Now I want to say 400 is not a valid value for a latitude. So you want the latitude value to be between between minus 180 to positive 180, let's say. How do you specify that? That can be only a value within a certain range. Well, you can go back here and say a public location, and you don't have to pass any arguments to it, but you can say if the lat is greater than 180, we can say a throw new runtime exception. For example, in this case, you can say error and you can throw it. Whether it's 180 or 90, you can put whatever value you want to. You can see it says error, and you can provide an exception as well. So that becomes what's called a compact constructor that can be used for such validations. It can be used for transformation of data as well in addition to it. And that's basically what a record really provides for you, is a very compact piece of code, as you can see. Well, I'm going to cover 2 more topics and we'll be done very quickly. And the next one is to show you some examples of what are called sealed classes and sealed interfaces. And I'll wrap it up with a quick discussion about pattern matching as well. And we'll be done right after that. So what are sealed classes and sealed?
Sorry for interrupting. We have a question about the records. Question is, are records right candidate for ORM frameworks like Hibernate?
Right. So first of all, thank you so much for the question, because I was getting, really worried that maybe I'm just talking to myself here, maybe I'm in the middle of a dream. So thank you so much for that question. I cannot thank you enough for asking that question. So records are really good candidates for definitely ORM mapping. There's no doubt about it. But it's also more than ORM mapping. We are living in the world of microservices and web services. So typically, if you're creating a microservice, you are exchanging data between microservices. So if you, for example, if you're doing a synchronous or asynchronous, let's say, communication with the microservice, typically you're going to get data using a JSON representation. When you get the data using JSON, you want to quickly convert to an object and make use of that object in your application. That data will go through multiple functions and transformations through your code. That is a great candidate for Racket. So you are absolutely correct. They can be really good candidates for OR mapping, but they are also great candidates for really a transformation of data through a system, through a web service as well. Whether it's a remote web service or a microservice, you can get data and transform through a record as well. So think of it as an object that is useful predominantly to represent data. It doesn't matter where the data came from. The data can come from a database, it can come from a file, it can come from a remote service, it could come from anywhere you want it to come from. It doesn't really matter. So that's the beauty of it, is that it's a data object and you can use it for anywhere you want to represent a piece of data. You don't want to use a record when you want to represent a powerful abstraction. If you are representing an abstraction with a lot of, let's say, behaviors in it. For example, you want to provide a method, let's say, which is going to do powerful operations in it. You don't want to use a record for that purpose because you really want object modeling. If you want to create a hierarchy of objects where one type may replace another type, records are not suitable for it. But records are a great idea if your goal is to represent merely data objects, right? That's what they really are for, and definitely a great candidate for that as well. So again, thanks for that question. I hope that answers your question. So you're right, you can use it for OR mapping, but a lot more than that as well. Great. So now let's talk about what is sealed and where does it go. They call this as sealed classes, but really it's sealed classes or sealed interfaces. You could use it for either one of those. It doesn't really matter where you're going to use that. But let's think of an example before we go into why you may actually need it. I want you to think about an application before we go further. So suppose you are creating an application that uses a plugin architecture. So just sit back and think about that for a minute. You're creating an application that uses a plugin architecture. So you or your team, right? Your team develops the core of the application. So you have a core of the application. The users of your application or your clients may provide plugins. So they are going to provide plugins. And what does your code do? Your code says, I've got a bunch of plugins come in. I'm going to use reflection, query about what's available, and make use of it. So all this is great so far, isn't it? From the modeling point of view. But let's pose a question. You, let's say, have an interface and you want your users, clients, to use that interface, but you don't want them to implement any class that that derives from your interface. So you want to be able to define an interface. You are telling your users, go ahead and use those interfaces. That's fine. There are other interfaces you can implement, but this interface is for you to use, not for you to inherit. So you have a client code. Your client code is going to rely on your interface, but you want your class really to extend from your interface like so, right? So your class is going to extend from your interface. You don't want your client classes to extend from your implement from your interface. So the question is, how do you limit the users of your code to use your interface, but not to extend or implement or derive from your interface? As it turns out, that's really hard to do. Here are a couple of things you could have done in the past. One idea is your code can examine objects at runtime. And if the object is of your type, yay, that's great. If the object is of their type and they extend or implement from your interface, you could give them an error. Good news, you can control what you want to control. Bad news, it's a runtime behavior. They don't get the error at compile time, they get the error at runtime. Darn it, that didn't work really well. Well, here's another idea. You can put your interface in a separate package and you can make it package friendly. Good news, they cannot extend or implement your interface. Bad news, they cannot use it also. Darn it, that doesn't work either. You could come up with a third option. You could devise your own annotations, and users of your interface are required to annotate their classes. Then you write an annotation processor. Your annotation processor can examine the code and say, no, you shouldn't inherit or extend from my interface. Once again, that's a lot of code to write, error prone, more work to do, more maintenance. Raise your hand if you want to write that code. Good job. I did not see anyone raise the hand. Exactly, right? Nobody wants to write that code. That's not a very fun situation to be in. Well, how do we then solve the problem? So what do we want to really do? As we know, abstract classes can have any number of derived classes. Final classes cannot have any child classes. We want something in between. We want to say, here are the classes I will permit, and nobody else can inherit from my interface or from my class. So this leads to what's called an algebraic data type in computer programming, and this is where the sealed classes really come in. How do we make use of it? First of all, I'm going to create right here a traffic light.java. So my interface is called traffic light, as you can see right there. And then I say a class called red light is going to implements the traffic light, as you can see. Similarly, I'm going to go ahead and write a next class, we'll call it as a green light, which implements my traffic light as well. But I'm going to make this as a sealed interface. I'm going to make this as a final class and a final class as well. So now we have a red light, maybe even a yellow light we can write. And then finally, we can say a green light, all that implements the traffic light. Going back to the sample, I'm going to say traffic light, and we can say in this case a traffic light is equal to new red light, and I can output a traffic light like so, and you can see we created an object of that traffic light, not a problem. However, if I go back and say class a broken light implements a traffic light, and now notice that I get a compilation error. What does the error say? Class is not allowed to extend a sealed class traffic light. So in other words, a broken light is not a member of the hierarchy that you see here. So you're not permitted in this case to extend or implement the sealed interface called traffic light. So by default, this is the behavior. The classes in the same file are the members of that sealed hierarchy. Classes in other files cannot be the member. Good news, that's nice to implement, easy to do. Bad news, rather restrictive. What if I want these classes to be in other files? What do I do? So what I can do here is to go back to this code. As you can see, it's broken. And I say, in this case, class flashing, let's say, light. So I implement a new thing called a flashing light. But how can that be permitted, you may ask? Well, I go back here and I make the flashing light a final class as well. But I go back here and say sealed interface traffic light, in this case, permits, and I'm going to list a red light, a yellow light, a green light, and a flashing light as well. So now when I run the code, you can see it has no problem because you listed using a permits class all the children that are supported by this class hierarchy. So as a result, what's going to happen? In this particular case, you can have a client code which is going to depend on your traffic light, but the traffic light only contains 4 permitted classes that derive from traffic light. So in other words, you know there can be no other class to implement the sealed interface, though any class may use that interface. In this case, associate, association or aggregation is perfectly fine, but inheritance is not. So that's an example of using a sealed interface where you can decide what classes on this closed hierarchy and what cannot. And there are several benefits to this. One benefit is you can define your hierarchy really well. Another benefit of this is when you mix it with pattern matching, this gives you a nice way for you to really perform a pattern matching without a default, because you can verify, the compiler can verify all the possible combinations are already handled really well. So that's basically about the sealed classes and how the sealed classes can work really effectively to solve the problem we talked about a few minutes ago. Very, very powerful. So the last thing I want to mention here is about pattern matching. Well, the switch expressions have grown into a beautiful pattern matching syntax. And I'm going to talk about pattern matching, show a quick example of what it can do, and then I'll show you how this can work with dominance and guarded patterns as well, and see how that can be really beneficial and powerful. So let's talk about this here with an example of a pattern matching. So essentially, I'm going to say output process, we'll call a 1, but I'm going to also send a hello as a string in here, if you will. But I'll also go ahead and pass here maybe an apple here as well. I want to see how we can use these in pattern matching. Well, first of all, in here, you can say public static, let's say string. We'll call a process which takes an object. We'll call it as an input. And the first thing we're going to do here is to say return switch as an expression. We'll say input right there. And I'm going to say a default. And in the case of a default, we'll simply say whatever like we did before. So that returns a whatever for the 3 values that you see. However, I'm going to go back in here and I'm going to say a case, an integer, let's say number, an arrow, and we can say you gave plus, let's say, a number. So you can get the number and you can return it. It says you gave 1. So this becomes what's called a pattern matching with instance of. That's what you're seeing here, a pattern matching with instance of. You can, if the object given is an integer, number is a variable that is of type integer, but refers to the same object input that you are referring to. You can also do the following. You can say a case string, and you can say fruit. And in this case, you gave, and you can say a fruit in this case. So essentially, in this particular case, we can output a fruit. And obviously, it's going to say you gave a hello, but that's okay. We'll come back and fix it in a minute. But in here, you can write what's called a guarded statement as well. So you can say case string fruit when you can say a list of, let's say, apple, comma, orange, let's say a dot contains the fruit. Then you can simply say you gave a fruit. So you can say you gave a fruit and you can return the fruit, right? Like so. So when you run the code, you can see it says you gave the fruit apple. It also says you gave a fruit, let's say in this case, an orange, and you can write that as well pretty nicely. However, you can also go back here and say a case, and let's say string, some string arrow, and you can say got a string of length, and in this case I can say a string dot length, and I can call the length function. So you can see it says got a string of length 5. This is for the hello that it gave us a string of length 5. Now when you look at this particular code, there are a couple of things you need to keep in mind when it comes to this pattern matching syntax. The first is we saw the pattern matching with an instance of nicely, and we can use a type matching. You can do a matching with different types and give a variable. But here comes a few different interesting things. You can match with the null as well in here. So what if, God forbid, somebody calls this function right here and says process and sends a null? The default behavior of switch is to blow with a null pointer exception. Notice that what you got in the bottom, a null pointer exception, which is rather unpleasant. You can say case null arrow, and you can say got a null, which is the response you're going to see now. It is got a null. So you can mix the null with the type also if you want to. But I want to show you the dominance, which is amazingly powerful in here. For example, if you notice these two case blocks you see here, this says I want a fruit when the fruit is in that particular list, versus this is a string. And the code is working fine right now. But what if I take this string and move it up here? If I take that string and move it up there, pardon me, if I take this string and move it up here, what's going to happen? If it's a string, it's going to say got a string of length. My goodness, what if it's apple? It's going to say got a string of length and print the length of apple. But what about this? That's more appropriate, isn't it? The compiler is keeping an eye on you. So it gives you an error saying, error, there's a problem with dominance. This is dominating all the call when this should have evaluated. And so this is a compilation error. When you move this down here, you can see the error goes away. That's an example of dominance. And the last thing I want to show you here is the completeness. So we already saw the guarded and dominance together. What about the completeness? The completeness basically in here is that in the case of the completeness, what if I don't provide the default? notice the compiler gives me an error, because what if the given value might be one of another value that could implement from object? So the default is required in this particular case. However, if you have a slightly different situation, let's say I have a process here, as you can see, and in the process, I'm going to take a vehicle as an input. So back here, I'm going to say a process a new, let's say a car, or process a truck as well, like so. So in here, I want to then say, in the case of a switch, and we'll say return switch input. But guess what I'm going to do now? We have an interface, we'll say sealed interface called vehicle, and we have a final, let's say a class called, what do you want to call it? A car implements, let's say vehicle, and you have a truck that implements a vehicle. You can say in here a case, and you can say car, and you can say output. You could say, got a car, for example, and you can say a truck, and you can say this is a truck, and you can say got a truck. So in this particular example, you have a switch, and you are saying you're going to take a vehicle as an input, and you're going to do a switch on the input. And because it's a vehicle, you check for a car, you check for a truck, and you return a value based on it. And then you say, I want to process for a truck here, or I want to process for a car, like so. Well, on line 17, it's not happy with me. Let's go to line 17 right there. And on line 17, it's complaining I have a parenthesis missing. Let's provide that. Run the code, got a car, got a truck. Notice it did not care for the default, right? No need for this. Why not? The reason is this is fully covered. The switch says, look, the vehicle can be either a car or a truck because it is sealed. And you took care of car and truck, no problem, no need for default. However, if you don't, pardon me, if you don't have a truck right there, then it's going to complain to you that it's not complete. The switch expression does not cover all possible input values, and in this case, default is needed, right? So that part is needed if you don't cover all the path, but all the types. But because we cover all the type, you don't need to put a default, and I encourage not to put a default. That way, if you were to add a new type, they actually write a default for you behind the scene, and that will tell you you have an unhandled situation, and you can go back and handle it appropriately at the time rather than doing it ahead of time. And so that's basically about pattern matching and how powerful that particular feature is. Well, that's all I have. I hope that was useful. Again, thank you for taking the time to join. If you have any final questions or comments, I'll be thrilled to answer it. Otherwise, we can wrap this up. Thank you.
Yeah, we have one question regarding the records. Can we use records as value objects in DDD, domain-driven design?
Well, typically they are entities more than value objects.
Mm-hmm. And one question is, we don't need DTO objects anymore after records, right?
Well, records are DTO objects, but done with a clear intention. When you write a DTO object in the past, you have to put a smelly DTO on it because there was no syntax to show it. Whereas in this case, the intention is very clear. So records are DTO objects in that sense.
Cool. And there was a question from Emre, but it's, will you also talk about memory management and garbage collection improvements Java had since? But yeah, it's clear. And one question from Fatih. do you see any benefit of var keyword, VAR?
I do. There's a lot of benefit of a var keyword, because if you are relying on type inference, it makes the code less noisy. So when the intention is fairly evident from the code, the types are pure noise. And especially when your types are really, really big. What if you have to write something, for example, like, you know, a map of, let's say, entity, you know, type, comma, list of some other type, and then variable is equal to, get the value from a known, let's say, API, or you can just take that away and you can say var meaningful, right? Full name, you can specify that. So, and rather than calling it as a, right? So if you ask me, do I prefer a useless name for a variable and a long type, or do you provide a meaningful domain-specific name and a var? I prefer this over the previous one. So there's a huge benefits of var in reducing the noise in the code.
Great. Any questions? I don't see the questions. But so that's okay, I guess. Thank you so much, Venkat. It was a very, very great descriptions and informations we had. Actually, I really like to see in Fly the especially records and pattern matching. And for the audience, just I want to remind that Venkat has a brand new book, Cruising Along with Java, from Pragmatic Bookshelf. So this is just I want to also tell the people.
Thank you so much. Thanks for having me. I really appreciate it.
Yeah. Thank you so much. And if any questions last minute, I think we are okay. There are no questions. Yeah. So everyone is saying thank you. Yeah. Everyone is writing the greetings and thank you message. So,
thank you so much.
I hope we will meet in another meeting or in another conference. Thank you so much for very good explanations and being with us. So keep an eye on our meetup page, guys. We will update for the future meetups. So thank you, everyone, and thank you, Venkat, again.
Thank you.
Have a nice day. Have a nice evening, people. Bye-bye.
Thank you.